Okay, Math 9s, welcome back. In this one, we'll look at Exponent Laws 2, or Section 2.5. The focus with this section is going to be to understand and apply the exponent laws for three different ones: power of a power, power of a product, and power of a quotient. Okay, so the first one we'll look at is power of a power, and a definition of that is this is just a power raised to another power. Okay, so a couple of examples here. So we have a power 2 to the power of 4, and that's raised to another exponent of 3. Okay, so again, exponents are a shortcut for repeated multiplication. So if we write that out, 2 to the power of 4 times itself 3 times, and then write it out with the really long terms, you get the idea that we're going to be able to count up the number of 2's here, and in this case, there are going to be 12 of them. Okay, so what we'll quickly see is, again, our exponents are going to relate 4 and 3. In this case, we're going to end up multiplying our powers. Okay, so if we do the same thing with this next line, if we have negative 4 cubed, so that's negative 4 to the power of 3 squared, so times itself, and then write that out in the above format. If we have negative 4 times negative 4 times negative 4, if there's negative 4 cubed, and then times that again by itself, times negative 4. As a single power, we're going to end up with negative 4 to the power of 6. So again, that's taking these power of power, so 4 to the power of negative 4 to the power of 3 squared. We can multiply those exponents and get 6 as our exponent in our answer here. Okay, so exponent law for power of a power goes like this. We are going to keep the base and multiply the exponents. Okay, and we can show that algebraically as some number to the power of m. If that's raised to another power, then we can keep that base and multiply the exponents. Okay. Okay, next one we'll look at is power of a product. Power of a product. And I wouldn't really concern yourself too much with remembering these names. I think it's more just remembering that, hey, when we have exponents that is just repeated multiplication, we can always write out repeated multiplication to sort of figure out what our exponent laws are. So with this one, if we have, this is just saying, hey, if you have a product, or 2 times 5, raised to a power of 3, what does that look like? So repeated multiplication, again, we can write 2 times 5 times itself 3 times. We can rearrange our multiplication statement to group together, and that's all we've done here, is we've just grouped together things that that are going to be useful to us, and this is going to end up looking like, hey, that's just 2 to the power of 3 times 5 to the power of 3. Okay, so again, we are going to look at the relationship between these exponents, and in this case, there's some hidden exponents here. 2 is actually 2 to the power of 1, and 5 is 5 to the power of 1. So we have to remember that any number by itself, we can think of it as being an imaginary power of 1, and that's going to be important when we actually get down to the definition for this thing. Okay, so if we were to write out this next one as repeated multiplication, it would be 3 times 4 squared, or times itself. We can rearrange to group our 3's and group our 4's. We'd end up with 3 to the power of 2 times 4 to the power of 2. Okay. And then if we were to write this out with words, we'd say, okay, so we are actually going to apply we're going to apply the exponents to each base in the product. Okay, so if we have two numbers like a times b, all raised to the power of m, then we can rewrite that as a to the power of m times b to the power of m. Okay, so that's for the power of a product. Okay, so in a similar fashion, just going to keep scrolling down here. In a similar fashion, but just to shorten this up a little bit, the power of a quotient is very similar, but in words, I'll scroll back up a little bit here in words. This is just taking the power of numbers that are divided. So very similar to the power of a product. So in this case, like just a quick example here, if you had like 5 over 2 raised to the power of 4. Okay, so we have to remember that the 5 over 2 is in brackets, so we can rewrite this thing as being 5 to the power of 4 over 2 to the power of 4. So very similar to our power of a product. Okay, so in this one we're going to apply exponent to both bases. In the division. And as a general form, we could say, okay, well this time if we have a quotient raised to a power, that power can be applied to both numbers in that quotient. Okay. Okay, so what this looks like with well, there's 6 examples here. We're just going to simplify these powers. We're not actually going to evaluate them, so we don't need a calculator for this because we should be able to. This would be some multiplication or addition of just some numbers which we're used to. So number 1, if we have negative 7 raised to the power of 3, and then also all raised to the power of 2, that base is going to stay the same, and we are going to multiply those two exponents. Okay. In this next example, I'm going to kind of forget that negative sign is there. I'm just going to forget about that and remember that that's got to be added in at the end here. So this is 2 to the power of 4 to the power of 5. So that's going to be 2 to the power of 4 times 5, or 2 to the power of 20. And then the negative sign out front just makes that entire thing, the entire answer, negative. Okay, number 3, in a similar fashion, will become 6 to the power of 2 times 7, or 14. Number 4, this is one where we can separate this product that's inside the bracket. So this become negative 7. We can separate that by applying the exponent to it, and then multiplying the other base, which is 5, and raising that to the power of 2. Okay. Number 5 and then number 6. Number 5, well, actually, with number 5, we could just do 24 divided by negative 6. And we could do what's in the brackets first, and that's going to be negative 4, all raised to the power 4. Totally legit. If we were going to rewrite this as using the exponents, this would end up being 24 raised to the power of 4, and then we have this negative 6. Also to the power of 4. Okay, and if you were to, so either one of these is true. It's a bit of a silly question. I kind of messed that one up. This should, anyways, you can do that in either of those two ways. Okay, number 6 is another power of a quotient. So we have this power, or this exponent of 3 outside. So our inside will end up being 78 to the power of 3 over 13 to the power of 3. Okay. Okay, and that's the end of exponent laws. So there are really three big ideas in this section, and those are three new exponent laws. If you have a power raised to a power, we can multiply those powers. If you have the power of a product, if AB is a product, all raised to the power, we can separate that and say, okay, that's going to be each base with the exponent applied to it. And lastly, if we have the power of a quotient is A over B raised to the power of M, we can separate that so that exponent applies to both the top base and also the bottom base. Okay. Okay, so a few questions to try from this section. Let's do page 84. And for all these questions that I'm writing out, 4 to 8, 10, 14, 16, and 19, let's do 3 from each. So we'll just do A, C, E from each one of those. And then a challenge question on here. Actually, two challenge questions are numbers 20 and, and number 21. Okay, come to class with any questions and we'll go from there. Bye for now.